there are two structures. Let me label them as A and B. These are two resonance structures, as this arrow says, or as this arrow shows. So which structure is good and which is bad? Okay, so first of all we need that what elements are present. Here there are CH3s and CH and CV, the 3 chlorine atom. Again, this is the same structure. This is another resonance form. From another resonance form, I mean that it should have the same elements present, or otherwise it would be something else. And the order of the atom is the same. It is again very necessary for resonance that the order of the atom is same. From order I mean the connectivity of the atoms is the same. So this is here positive charge is on this carbon. Here the positive charge is on this carbon. And as you see that both the carbons, they are secondary carbons. Secondary carbon mean that they are attached to other carbons. Okay, but this structure is very bad, and this structure is very bad, and this structure is okay, a little bit okay. Then this is good. This structure is not very good. This is both the structures are not actually good, but let's say when we compare those structures, this is worst and this is good. Why? As you might have studied the inductive effect, anybody who is confused, they need to watch the previous videos. That the title of those videos were role of electronegativity in resonance and role of inductive effect in resonance. And there we discussed that how the positive charge is stabilized, how the negative charge is stabilized, and what is inductive effect and what are its applications. So it is the application of the inductive effect. Okay, as I need to exaggerate these charges a little bit so you will understand it more. As this carbon has 3 chlorine atoms, so this is partially positive. It is from this thing, it is partially positive because those chlorine pulls electrons from the bonding electron away from it, and it now what it will be doing, it pulls the electron from this bond. So the electron of this bond might be not right in the middle, it will be very near to it. So what will happen, as this is a positive charge, and a positive charge means it is unstable because it needs electron. If you pull the electrons, the bonding electron away from it, it will need the electrons very much. So I just want to write it in an exaggerated form. It is not real, but you will understand. Now this positive become very big. Still it is 1, but this thing become very unstable. Here in this case, as you see, that this group is very farther away from each other, and here the carbon needs electron. It's not a stabilized carbon, but it needs electrons. So but it has an electron donor group here attached. Okay, this pushes electron into the positive charge, so that you can say that it is smaller. We need to be, so this is stable and this is unstable. Okay, now what if here we had some negative charges on those structures, a negative here and a negative here, then which one will be very much stabilized? Okay, these are just a bond pair, okay, or electrons which form the bond. So I should, okay, now as you see, look to those structures. Those here the charges are now different. I just placed some other charges because our motive is the general definition say that stabilize the negative charge and stabilize the positive charge. So here we don't have any positive charge, we just have a negative charge. To how to stabilize it? This here, as you see that here this chlorine extract the electron out of it and pull the electron from this carbon, and this carbon pulls the electron through this bond, and this carbon, the negativeness of this carbon decreases. As the negativeness of this carbon decreases, because this carbon is having more burden on it, more burden of electrons. So when it pushes the electron, so the electron, the spread electron, because the electrons are very spread, you just view as the electrons are very much spread. But as these chlorine pulls the electron out of this carbon through these bonds, so this carbon is become very much partially positive, and now it pulls electron toward itself. And what happens, the negative charge, or because the electrons are cloud, so the clouds shrinks, and you can say that it is unstable. So I can write it in a shrink form, and we just can write it like small negative charge. What about here? An electron donor is pushing electron into it, and here the electron donor is pushing electron into it, and it increases the cloud. Because electrons are clouds, so it increases the cloud. So we can write it in another form. This form, you will like it. So we can just write it big negative. So this is unstable. Big negative is unstable, and big positive. So if again it is not clear to you, please watch those videos, the previous videos on the resonance. Okay, it will be clear. So this is bad. Now this becomes suddenly very good, because these electrons are available for the outside, and they are not available for the outside because they are shrink. They are very much near to the nucleus in comparison to those, they are spread. Okay, so this is good, this is bad. So let's see, let's look at those structures. This is a structure, one an alkyne and an alkene. Okay, and they are in conjugation. So as I told you that we cannot draw a single Lewis structure for it. Now what happens, these are the two resonance forms of this molecule. Okay, so I should not repeat all the things, okay, this structure is formed, this one, when both electrons come and sit on this carbon, and those electrons come and form a bond. Okay, you will get that structure. And what about this structure? You can get this structure by when these electrons, the electron from a triple bond, come here and they sit here on this carbon. Okay, there are other structures which are not important, because in the middle, which are not important because they will create a large number of charges. So therefore they are not very much relevant. Therefore I am not trying them. This is another structure. Okay, so now our aim is to discuss which is good and which is bad. Still we don't know that what will be the actual structure looking like. Okay, but now right now we need to understand that which is good and which is bad based on our previous knowledge. Look at this structure. As you see that this here, negative charge is on the carbon and a positive charge is on a carbon. Both are primary type of carbons, positive here and a negative here. But there is other thing which we discussed in the previous lectures or videos, that the more the S character, the more the carbon become electronegative, or it attracts the electron toward itself, or it forms a short bond. Okay, the carbon, when the electron form a short bond, when the carbon form a short bond, there are protons in a carbon, and the electron is positive. So the positive and negative has a strong pull on it. Okay, but for this course you can say that when there is more S character, then the carbon become a little bit more electronegative. So you can also say that. So this is an sp carbon. Okay, and so it was an sp carbon, and when electron sits on it, so what happens? So it becomes sp2. Now this is sp2 carbon. If you have problem in understanding those things, so you need to study the video series on hybridization. There I have explained all the things, all those things, that how one hybridization changes to another. Okay, when an atom acquired a charge. It is sp2 or sp squared. This carbon is sp2, and this carbon is sp. Now, as just I told you that you can also think of this carbon as more electronegative, and this as a less electronegative. Or in other words, you can also say that when a double bonded carbon, okay, so the double bonded carbon is more electronegative than a single bonded carbon, singly bonded carbon. From that I mean that if you have those two this molecule CC and CH3, okay, just for understanding, okay, so you can just think that this is more electronegative carbon than this one, okay. So here in the above case, as you see that you have a negative charge on sp2 carbon. It's okay, because negative charge is because the sp2 or sp squared carbon is more electronegative than sp3. So this is okay, this seems okay, but you are comparing this with this, and here the positive charge is on sp2 carbon. So again, it seems that you can write it's okay. It seems like okay that if this is sp2 and you have positive charge on sp2 and a negative charge on sp2, but you need to learn that positive charge on sp2 is bad, okay, and negative charge on sp2 is good, okay, but you don't have any chance. But what is our aim? We need to compare those. Now let's move to this. Of a positive charge on sp carbon, it is worst, because we think in our just from our intuition that the sp carbon is more electronegative, and I wrote a positive charge on a more electronegative atom and with incomplete octet. Again, this is incomplete octet, okay, but it is sp2 and this is sp, so it's not good. Now let's move to this one. What's a negative charge on sp3 carbon? So there I just told you that sp is more electronegative than than sp2, and sp2 is more electronegative than sp. So here, if you ignore this structure and look at this structure, the sp3, you can see that sp3 has when you are comparing two structure sp and sp3, and I wrote the negative charge on sp3 in the presence of sp carbon. So this is not good, it is bad, okay. Here again both are sp2, so you can say that maybe it's okay or it's not okay. But when we compare those structures, here positive charge is on sp, here positive charge is on sp2, so this seems good, okay, this is very good. Here negative charge is on sp3, and here negative charge is on sp2, so this wins. This is good structure and this is bad, because negative on more electronegative, negative on less electronegative, positive on not very much electronegative or not very much less electronegative, okay. So positive, we need to compare the positive charge on very much electronegative atom and the positive charge on less electronegative atom. So this is bad. We need to stabilize the positive charge. The positive charge need to be on less electronegative atom. This is good. The negative charge need to be on more electronegative, then this structure is good. So this is worst structure. This is the best of the best structure, because no charges and many covalent bond. Here there are two charges and this is good structure. So this is very good, this is best, this is good, this is worst. Okay, there are other structure in the middle, you can also write those, but those are not important because they will create charges. Suppose here the electron sit on this carbon and the electron here sit on this carbon, so this will be positive, negative, 4 charges. So the more the charges, this thing is not good, so I am not writing those. You can write this in the other form too. Even worse structure will be produced. A positive, a negative, positive, a negative, 4 charges. So the more the charges, the poorer the structure. So I am not writing those. I am comparing those two. So this wins with a clear-cut margin. Okay, and this poor fellow loses. Okay, so we need to look at those structures. This is the main structure, the best of the best. Okay, and it can produce 2 other structures with 2 charges each. This is a positive, this is a negative charge. This is a positive and this is a negative charge. Now, because we need to be, you have studied those structures and it will be easy for you. So let me just tell you the answers, clear cut. This is good structure, this is bad. What is the reason that this is bad? The reason is that the positive charge is on the secondary carbon and negative positive. So let's move to the positive charge is on the secondary carbon. Here the positive charge is on the tertiary, so it positive wins. What about the negatives? The negative charge on a tertiary carbon with an electron donor groups, it's bad. Negative charge on a secondary carbon, this is good. So this structure wins with a clear majority. This is wrong. This is best of the best of the best of the best. This is second best. Okay, so these are the other structures. So let me draw another structure. This example, I think that you have done it a little bit earlier. CCl3. Okay. Suppose this is a structure, okay, and I should write both the resonance form of this. Suppose both the electron shifts to this carbon. You will see it like this. Or in the other case, when both the electrons move like this and sit on, suppose it is very difficult from here to write, so it sit on this carbon. Okay, our aim is just to understand the things. Now these things become very easy for you. This is the best of the best structure, as because it has more covalent bond and 0 charges. These have 2 charges. Now let's compare those two. Positive on this positive charge is present on secondary carbon. Here the positive charge is present on a tertiary carbon, but here 3 chlorine atoms are present. So this is not a tertiary, it is very bad. So what will be happening? Now these CCl3 groups, the carbon, this chlorine will pull the charge from the carbon and it will enhance it will destabilize this positive charge or make it big or make this carbon even more thirsty for electrons. So when carbon is more thirsty or more positive, so it will need electrons, so it will react very fastly because it needs electron and it will acquire it from anywhere. Okay, it will be searching for electron. So this structure is bad. Here the negative charge is near to the electron withdrawing negative inductive effect atoms. Okay, this has negative inductive effect, so a negative charge is small. This positive charge is again not big, not small, it's okay, but definitely this positive charge is smaller than this one. So we can write it in our own exaggerated form. Now this negative is smaller and you can write this small positive. This wins with a clear-cut margin. This is the best of the best, this is the second best. Okay, so now we need to study what? The contribution. The contribution is the important part, which will show us that which structure is, what is the behavior of the structure